Now the next speaker, Dr. Romain Duprat from UPenn. Romain, are you with us?
Yes, can you hear me?
Perfectly well, yes.
Awesome. All right, first, thanks for this opportunity. I really appreciate it. And we heard so many amazing talks yet, so hopefully what I will show you will interest you. So I have some results to show you from an ongoing study. So first, this is the first part of the study. So just to explain you a bit the setup, what we first did was to acquire resting states from depressed patient and healthy controls, use those resting states to design individualized target based on functional connectivity. We were mostly interested in the subgenual anterior cingulate cortex, of course. So we use the functional connectivity maps to design those targets at the individual level. And we use control target as comparison. And those control targets were based either on the functional connectivity to other region of interest, such as the amygdala, or based on anatomically features. And then we put our participant into the MRI, stimulated them with single pulses, and extracted the signal percent change in the region of interest, the subgenual anterior cingulate cortex. And here what we were interested in was the relationship between the functional connectivity at the site of stimulation and the evoked response in the subgenual anterior cingulate cortex to see if we were able to modulate that region, and if yes, how does the functional connectivity at the site of stimulation relate to that evoked response. So next slide. So here is what happened when we put our extracted evoked response into a GE model. We found that there was no relationship between functional connectivity at the site of stimulation and the evoked response in healthy control, but in our depressed patient, we saw that there was a significant effect. And that effect showed that in this cohort, the stronger the functional connectivity at the site of stimulation, the stronger was the evoked response in the subgenual anterior cingulate cortex. And that response was mostly a negative pole response. So to put it in a simpler term, for every 0.1 increase in functional connectivity, we observe an average of 7% stronger negative pole in subgenual. Next slide. So how does that relate to our TMS and treatment? Well, in the second part of the study, we also provided like 3 days of ITBS, so some kind of like a mini treatment to our patients, patient only, over the subgenual targets and only the subgenual targets. But we also use the amygdala functional connectivity-based target as a control to assess the specificity of our treatment and stimulation. Next slide. So here on the left, you can see a plot of how the evoked response at baseline relates to the post-intervention depression state of our patient. And what we found was that the stronger the evoked response in the subgenual anterior cingulate cortex at baseline was, the better the patient did in after the mini treatment that we provided. So that might suggest that a more intact pathway contributes to depression improvement in our TMS treatment. But what's also very interesting on the right, you can see here, we plotted the pre and post-intervention evoked response in the subgenual anterior cingulate cortex and the amygdala. And next slide. What you can see is that the post-treatment evoked response in the subgenual anterior cingulate cortex was stronger. So it becomes more negative than at baseline. On the other hand, in the amygdala region of interest that we looked at as a control, we found no such effect. On the opposite, we found a weakening of the evoked response. So it tended towards a null signal change there. Next slide. And so we were also interested in how the evoked response in the subgenual anterior cingulate cortex related to symptom change after this only 3 days of ITBS. And while we found no association with anxiety, we found an association with depression. And like, although the average subgenual evoked response became more negative in average following the intervention, the patient with the most depression improvement tended to exhibit a weakening or a positive change in their subgenual anterior cingulate cortex evoked response. So next slide. So as a summary, what we found here is that we use single pulses in MRI as probes to assess the efficacy of like cortical targets and assess a relationship between functional connectivity and evoked brain response. And what we found was that a higher functional connectivity at the site of stimulation led to a stronger modulation of the distant target, the subgenual anterior cingulate cortex. We also found that the pre-intervention evoked response in the subgenual was associated with depression improvement, and that's, I think, very interesting in the sense that maybe we will be able to use single pulses in MRI to assess whether a new target will be efficient in treating depression before going on with treatment. And finally, we showed that patient. Oh, yeah. Okay, we can stop here. Yeah, we showed that patients with the most depression improvement tended to exhibit a weakening in their subgenual evoked response. That's it. And thank you to my team, of course, and especially Desmond Odes.